LeChatelier's principle. LeChatelier's principle states that when a system is subjected to a stress, the system will shift its equilibrium point in order to relieve that stress. So basically what that means is if we have a system that has established equilibrium and we change some factor about that system so that it's no longer at equilibrium, that system will do whatever it needs to do to reestablish that equilibrium. So let's use this as an example. Let's say that we've got nitrogen gas and hydrogen gas, and we produce ammonia, plus it's got in there the fact that it's an exothermic process. It gives us the energy that's released during that process. So 92 kilojoules of energy. And the system's at equilibrium. And then we increase the concentration of any of the components on the left-hand side. So we add some nitrogen or we add some hydrogen to that container that has a system of equilibrium. It's no longer at equilibrium. We've increased the concentration of the reactants. In order to reestablish equilibrium, our system is going to have to shift towards the right. And what that would do is it would decrease our reactants, increase our products, and reestablish our equilibrium. If we were to decrease any of the components on the left-hand side of our reaction, if we were to somehow get rid of some nitrogen or hydrogen out of the container with a system at equilibrium, it's no longer at equilibrium, and in order to get to equilibrium, we would want to produce some of the nitrogen and hydrogen that we had eliminated. So our system's going to have to shift towards the left. Let's say that we decrease the volume. Well, by decreasing the volume, we increase the pressure. The system won't be at equilibrium, and it's going to want to shift in order to decrease that pressure. So in order to do that, it's going to shift to the side that favors the least number of moles of gas. So in this particular example, we've got 1 mole of nitrogen for every 3 moles of hydrogen on our reactant side. So that's 4 moles on the reactant side. And we have 2 moles of ammonia on our product side. If we decrease the volume, that will increase the pressure. In order to decrease the pressure, the system is going to shift to the side with the least moles of gas, therefore decreasing or relieving that stress on the system. So in this particular case, it would shift towards the right. There is no specific answer for this, though, because it depends on how many moles of reactant and product you have. If we were to increase the volume on this system, that would decrease the pressure and throw the system out of equilibrium. In order to reestablish equilibrium, we would want to increase the pressure, which means that we would have to shift to the side with the most moles of gas. So in this particular example, it would shift towards the left. Now, if we increase temperature, we're going to want to shift to relieve that stress. Again, it's going to depend on whether the reaction's endothermic or exothermic. But it's going to shift to the side that favors using up some of that energy. So in this particular example, we're looking at an exothermic process. The energy is on the product side. If we increase anything on the product side, the reaction is going to shift towards the left. If we decrease the temperature, our shift is going to be towards the side that produces energy. So in this particular example, because it's exothermic, if we were to decrease the temperature, our shift would be towards the right. So let's look at another example. Here we've got carbon monoxide and oxygen, and we're producing carbon dioxide, and it's also an exothermic process. So if we were to add oxygen, that's something on the left-hand side, it would have to shift to the right to establish equilibrium. If we removed carbon dioxide, we're removing something on the right-hand side, so our system would have to shift towards the right to reestablish equilibrium. If we increase the temperature, and this is an exothermic process, we're going to shift to the side that uses up some of that energy, so we'd have to shift to the left. If we decreased the pressure, we would want to increase the pressure by shifting to the side with the most moles of gas. We have 3 moles of gas on the reactant side, 2 moles of gas on the product side. So for this particular example, we would see a shift to the left.